Hi, yes, it's the last lesson for the week. It may seem like chapter two's not been so much fun yet, and we haven't had any biscuits, so we're going to make up for it by doing three in one. And I was going to start off with the chocolate digestive, which I know I gave some of you thought maybe a slightly harsh press. I didn't mean it. I just meant that I think it's a little overrated, but it's not a bad biscuit at all. So I'm going to revisit that and see whether or not I have to eat my words on it. Now we're going to be doing composite functions today, which you would have come across during GCSE. And for a little definition of what's going on and a reminder, just have a look at the graphic that's coming up. You'll probably want to copy it down, and then we'll get started. So copy these down, and whilst I munch through this biscuit, just have a go at what you think would happen. Pause the video and all that stuff. So what I would do here is, remember, it's the letter that's closest to the bracket that you're going to deal with first. So you've got to put 1 through G first of all, and then put it through F. So one way of doing that, as it's a nice simple one, is I could just write my value of X is 1. So I'm going to work that out and then put that through F. So I'm going to do F for 2. Now for 2, for X gets squared, so we're then going to have 2 squared, which is 4 there. On the next one then, we're going to do F first and then put that through G. So if it's 3, we're going to do 3 squared. So we're going to do G for 3 squared, which is 9. So that means that we're going to put 9 in as our value of X and then add 1 to it, which gives us 10. The last one, if you'll see F and F there, sometimes you can see F squared written as well. Then we're going to start off by doing F and then putting it through F again. So it's negative 2 squared, and then that's going to go through. So negative 2 squared is 4, and then we're going to do the same thing again. So that'll give us 4 squared, which is 16. Right. So there was actually a plain chocolate digestive, which is far superior to the milk chocolate version I'd just like to add. Alright, so I shall be dunking my ginger biscuit into the tea whilst you have a little go at what you think is going to happen here. So we're going to do G first, but this time it's just X that's there. And the point of what we're doing here is we want to know a single rule that will do this, because it's a bit of a hassle, isn't it? If I know a value that I want to put through, having to put it through this and then put it through that. So if we can just do it with the algebra once, we can make a new function which does the whole 2 sets of calculations in one. So G, when you put X through G, you're going to get X squared plus 4. So all we have to do is then write, well, I want F. I want to put X squared plus 4 through F. I started writing 3 because I was looking at that already. Now this is what goes into instead of my X in 3x plus 2. So that means that I can write 3x plus 2 instead of my X. So that'll need to be squared. And then, why would that need to be squared? That's complete nonsense, isn't it? I'm still looking at the wrong thing. That biscuit's put me right off. So we'll start again. So what goes in here? X squared plus 4 goes in instead of X. So we can say that that's going to be equal to 3 times X squared plus 4. And when we've done that, we still just need to add the 2 to it. So if I expand that bracket, I get 3x squared plus 3 fours are 12, and I've still got the 2 to add. So at the end we do a little bit of simplifying, and we get 3x squared plus 14. So 3x squared plus 14 will always give the same result as doing x squared plus 4 and then 3x plus 2. Right, the second one we're going to have a little go at is what happens if we reverse the order that we do it in. So this time what I'm going to do is I'm going to put f into g. So f is 3x plus 2. I'm going to put that into g. Well, what do we do in g? Well, we square whatever we've got. So 3x plus 2 needs to be squared this time, and then we add 4 to what we get. Now you may want to use a grid to square that. 3x times 3x is going to be 9x squared. You're then going to have two lots of 6x, so that will be plus 12x, and 2 times 2 is 4, and then adding 4 to that. And if we simplify that just by adding those 4's together, we get 9x squared plus 12x plus 8. Then a third one might have would be f squared x. Now that means exactly the same thing as if it had written ffx. So here we can say, right, when it goes through the first f, that will give us 3x plus 2, and then we need to put this in as our x in 3x plus 2, don't we? So we will have 3 times the 3x plus 2, and then adding the 2 on at the end, which gives us 9x plus 2 3's are 6 plus the 2, so just clean that up, gives us 9x plus 8. And then the last thing we're going to do with these two functions is we need to know the values of b such that function fg b is equal to 62. Well, we found out what that composite function was before. It was 3x squared plus 14. So we're going to make that equal to 62. And then it's just a case of solving this quadratic equation, which is not too tricky, because if we take 14 from both sides, we get 48. And then if we divide both sides by 3, we get 16. Oh, so x squared is equal to 16. And therefore, if we find the square root, we get plus or negative 4. Right, here's our final problem. You can write functions in this form as well. It means exactly the same thing as it was doing before. We've got something modular coming along, so have a little look at that, think about it. I have to admit that the ginger biscuit did not quite hit the spot in the same way that the digestive didn't. That's quite rare for me, but anyway, maybe it's because I've just had the digestive, who knows. Anyway, we're on to the good old favourite of the deluxe dark ginger. Right, so what are we doing? Well, the first thing to do is put 3 through g, and then we will do the f of that, but we will do that in the modular. So we will put 3 through that, so you've got 3 plus 1 over 2, which gives us 4 over 2, which I think we can just put that straight to equaling 2. And then we're going to put 2 into this, and this is modulus, isn't it? So we are going to be saying that that's going to be equal to, just put that outside it, just we work out what's inside it first, don't we? So that's 2 times 2, take 8. 2 times 2 is 4, take 8. So we're looking for modulus of minus 4, which means we can ignore the negative and just get an answer of positive 4. Right, now have a look at the next one. Solve fg of x equals x. Now, suddenly this is an equation. This isn't just a function that we're putting something through. And we're saying that that's going to be equal to that. Now, the first thing we need to know is what is this composite function? Well, we would do g first, wouldn't we? So g is x plus 1 over 2, and then we would do f of that. So let's just write it down that way. So if we keep the f there, we say, right, we're going to end up with x plus 1 over 2. That's going to go through there. Now, in order to get this, all of that has to go in as x, but then it's all within a modulus. So start by putting one of those up there. We're going to then have 2 outside a bracket of x plus 1 over 2, and then take 8, and all of that is going to equal x. Next thing to do would be to expand the bracket. It might be nice to think about x plus 1 over 2 as x over 2 plus 1 over 2, because then when you times those by 2, it makes it a little bit simpler, so that you've got 2 times a half of x is just x, 2 times a half is 1, and then we take 8. So at this point we're almost there. We've got x take 7 on this side equaling x on that side. So what the flip's going on? The best way not to get wound up about what's going on here is to make a sketch. So we're going to think about the sort of simultaneous equations that we did on 1 or 2 problems earlier on in the week, where we plotted y equals the left hand side and y equals the right hand side. So if I do a little sketch first of all of y equals x minus 7. Now I know I'm going to need to go away below the axis there. 1, 6, 5, 4, 3, 2, 1, 0. Now I know that y equals x is just going to be the straight line. I won't be lazy, I'll get a pencil out and do this. So it's going to be a straight line going all the way through there. So that's y equals x. Y equals x take 7. Well, that's parallel to y equals x, isn't it? That would be, well, all of this would be dotted, wouldn't it? Now before then, it's going to be coming in it's going to hit there when x is 7, because 7 take 7 would be 0 for y, wouldn't it? And then at that point it's going to reflect. So I could, by doing this sort of accurate sketch, I could say, oh, it looks like it's coming in. That looks like it's coming in at 3.5. And indeed it does. But let's just check out with solving it algebraically. We could have x minus 7 equals x. And how do I solve that? If I take x from both sides, x just disappears. Or I could, if you remember, have the negative version of it, which is what we have for, because it's got this reflected. So minus 1 outside x minus 7 equals x. Now if I times them both by -1, you get negative x plus 7 equals x, and then if I add x to both sides I get 7 equals 2x, and therefore if I halve it I get x equals 3.5, or 7 over 2, or 3.5, whatever floats your boat there. So why did we have this going on? Well, we had this going on because these lines here are parallel, and if you were just doing the line y equals x minus 7, they would never meet. So there would be no solution to x minus 7 equals x, because you can't take 7 from a number and still get the same number. That would be nonsense, wouldn't it? But you can get it with the modulus, because when that happens, that reflects it in there, and it's the point at which it hits there. And hopefully the sketch has made that much easier to work out what's going on. Now you're going to need some practice for this, and here you go. So page 34, exercise 2c, questions will be coming up just after this as well if you just want to look at it from there. There are questions 1, 3, 4, 5, 8, 9 and 10. Oh, and just for the record, the deluxe dark chocolate ginger, or ginger chocolate, whatever it was called, yeah, that did knock them both out the park once again. So hopefully next week we might have some different biscuits. In the meantime, so long, stay safe, and try and enjoy the weather if it starts to improve a little bit, hopefully. Goodbye.